at Porto, and he enjoyed the experience so much that even without the free dinner, he's back to show us some more interesting stuff.
Yeah, and I want to thank you guys from Porto for giving me the chance to be here speaking. There's still some survivors from my first talk, so we'll see. Just a quick intro about myself, just to give you an idea. For those of you who don't know me, I love learning. I'm a tester for a living. I'm also a developer. This year I started doing a lot of contributions to open source software, and it grew on me, and I'm getting very passionate about it. I work at Blip, Web Engineers. So if you don't know Blip works for Paddy Power Betfair. It's a gambling and betting site. You can check out my webpage. Over there you'll find links to my GitHub, Twitter, LinkedIn, whatever. And you can reach me by whatever means you want. So let's get to it. Let's talk about elegant objects. Anyone here ever heard about this? Elegant objects? No? By the way, just to get an idea, you heard about it?
Yeah, totally.
Just to get an idea, which one of you are front-end developers? Arms raised. Okay, back-end developers also. And you kind of full stack. Okay. So elegant objects is, if you had to explain it very, very simply, it's an object-oriented programming paradigm. So it's a model of something, or a very clear and typical example of something. It's deeply explained in a book written by this guy, Yegor Bugayenko. You can, that's his Twitter handle. He also has a blog. I have a copy of the book here. If you want, you can pass it around during the presentation. Check it out. It's divided into 2 volumes, and basically in the book, Yegor gives a set of recommendations on how you can have your object-oriented code much cleaner, with better classes, and the architecture overall much more visible. And a disclaimer before I start, you can find everything I'm going to talk here with you. You can find it out at Yegor's blog, on his YouTube. He also has videos explaining every single point I'm going to talk about in detail, and of course on the Elegant Objects books. If you are interested in buying the book, I know that he does a promotion. You send him an email and he will make you a discount instead of buying on Amazon. So let's get to it. So what are basically the recommendations of Elegant Objects? It's basically grabbing everything that we learn at school and we're used to, in a way, practice when we're programming on object-oriented languages like getters, setters, annotations, mutable objects, data objects. It's grabbing all of this and basically not using it or avoiding to use it. And if you had to sum it all up in terms of idea, it's basically you don't treat objects as data structures, or you don't treat objects as bags of data, as a bag of data with procedures to work and change that data. And the second point is maintainability is above everything else. So if you have the chance to make your code more readable, more maintainable, even if that has some decreases in terms of performance or other issues, if it is more maintainable, on the end, it's much better to use as a programmer. And the basic idea is to treat objects as living beings. So me and you, we were born one day and we studied. Most of us, I don't know about all of you, but we work, we have jobs, and there will come a day when we will retire. And just to give you some examples, let's focus on each of these steps. So birth, working life and education, and retirement. Let's talk about birth. Birth tells us about when an object starts to live. So, for example, Jaeger has this idea regarding elegant objects paradigm about code-free constructors. So, at school, we typically learn that a constructor it initializes an instance of a given object, and at school we're not taught. Sometimes we are, sometimes we're not, about how we should treat constructors, with how much respect we should treat them. So typically, sometimes inside a constructor, what will happen is we start to giving a constructor a lot of control over the state. We don't just use the constructor to create the object inside the object we're trying to create. And the proposal here is to keep your constructors code-free. So in a constructor, you should only see assignment to the variables of the class. That's it. You use a constructor to create the objects inside a given object and to get them ready to work. But you don't put the object itself at work in a constructor. For example, over there you have an example. You have the constructor to start the football results app. It gets some data as an argument, a screen, but on the constructor we just get it ready to work. We don't actually put the app running. We can do that much later in the code when we create an instance of the app and we set it running. So it might seem simple, but a lot of times we fall into this habit of sometimes in constructors, inside constructors, for example, we take an argument and sometimes we do some transformation on that argument and then we assign it to the object we're initializing. So the first proposal is you should keep your constructions as code-free as possible. The second is an object's name is not a job title. So if I ask any of you guys your name, it's different than your job title. For example, you can ask me, I'm Philippe, and I wouldn't like my wife to come up to me and say, hey tester, or hey programmer, do this for me or do that. She'll probably call me by my name, or if she's angry with me, she will call me by my full name. So when we're thinking about objects, we should not think of what the object does or his job title. We should think about its name. And this means avoiding the use of ER at the end of, or 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 whatever, at the end of the name of an object. So for example, we see a lot of this in the code we do at work. We see sometimes helpers, handlers, writers. We see readers, converters, observers, listeners, on and on. And we see this on a daily basis. I can speak to you about my personal experience. I'm currently we're currently developing in Scala, but back in my old company, we were developing, for example, in Java, and we saw this a lot. We saw the helpers, the writers, the readers. We saw this a lot. And the proposition here is to just don't use them. So it's basically to consider that an object isn't a link between worlds, and it's not a collection of procedures. So an object should be treated with enough respect. So an object is self-sufficient, and it represents the encapsulated data. I'll give you a simple example that's easy to understand. You can think in two ways. For example, you can think of a finder of prime numbers, or you can think of a list of numbers that only returns primes. On the first one, we're thinking about a job title. It's not very elegant in terms of object-oriented programming. On the second one, we're treating it with enough respect. We're treating it as self-sufficient. So we're saying we have a list of numbers. The only thing is this list of numbers returns only prime numbers. let's change a bit the topic here, and let's pass on to education and work life. I'll give you some. By the way, I'm not giving you everything that there is about elegant objects. I'm just giving you a few examples. You can learn more on Jaeger's blog and on his book. So, another idea is no getters and setters, not even once. Who here uses getter and setters on a daily basis? Okay. So Jaeger's proposal here is don't use them. Never. Not even once. And by now, you're probably thinking, okay, this guy is coming up to me and he's a bit of a lunatic. How on earth am I not going to use getters and setters in Java or in C++? How's that even possible? I use them every day. Again, don't treat objects as bags of data, ever. And I'm not going to go very into this, but you can remember, for example, the consequences of having, for example, a setter or a getter, meaning, for example, when you have a setter, that means that the state of your object is mutable, and that has its own consequences. And for example, when you have getters, you're a lot of times exposing stuff that should be encapsulated in your object. So don't treat objects as bags of data. I'll give you an example in terms, for example, of readability, how this looks like. For example, you can think in a very computer or procedural way of thinking or have this mindset where, for example, you instantiate a dog, you set the dog's ball, and you want the ball back, so you dog get ball. This doesn't seem very natural to us, but we're so used to it. We learn this at school and we use this every day at work that for us it's normal to think in this computer style. But I'll show you the same example, only in a more human style. So you have a dog, the dog can take a new ball, and the dog can give a ball. Now, if you look closely, there's no getter, no setter, no get, no set, nothing. But it's easier to understand. You can take your own ideas from this, but at least for me, it looks more easy to understand this example of code than this. If I have, for example, zero knowledge of programming. And this, since it's more understandable for us humans, it tends to be more maintainable. Another point is an object works by contracts. None of us, when we have a job, when we're working for a company, we don't work for free, right? We have a contract saying what we're supposed to do, how we're supposed to do it. That helps a lot. So it's the same for objects. Objects should always work by a contract. So you should always use interfaces. At least, for example, for Java and other languages based in Java, you should always try to make your objects use interfaces. I'll give you an example. I work for Blip, and Blip, since we are a gambling and betting company, we typically have these sort of situations where we want results for a given sports match. So I want results for a tennis match. And these results can come in from various sources. So for example, a given trader can give us an Excel sheet, whereas another trader can simply give us a text file or upload it to some service, or we can have a service speaking to another service or via JSON. All of these, for example, could contain the same results for the same tennis match, but they are modeled in different ways. So when you want the results for a tennis match, in this case, you would typically have, for example, different classes that represent that could represent the data you get from a JSON or from an Excel sheet or from a text file. And a good way to do this is to have all of them implement an interface. And the interface, for example, could extend another interface, like a game match. What you gain from this is that no matter what the source, for example, of that is, the contract always stays the same. So that means more decoupling and more maintainability. If I want to change in some way the way I read data for a tennis match from an Excel file or from a text file, I don't need to worry if I'm on the other end trying to read this, trying to get this data, because the contract is always the same. Another point is that a good object, I talked about mutability before. I'm going to talk about it again. A good object should never change its encapsulated state. So what does this mean in practice? In practice, it means being immutable. So a mutable object typically can change its state via after construction, for example, via setters or via some interactions we have with that object. That in turn has a lot of disadvantages, and I'll give you an example here. This, whenever you make, for example, an HTTP request, the result can change, right? But you can always guarantee that the state is always the same. So you know what your object is representing. And that's the beauty of it, that is, this is more maintainable than just giving the freedom and exposing this, and you're never sure if the page is pointing to the page you want if you allow another user to change this. So you set it to immutable. I'm not going to talk a lot about this. There's a lot of benefits you get by immutability, like thread safety, temporal coupling, and side effects, and identity immutability. You can read more about it at Jaeger's blog. But for those of you who are into concurrency and those kind of issues, there's a lot to gain from when you actually care about immutability in objects. Let's talk a bit about retirement. And I'll just give a simple example of this. Never accept null arguments on your objects, and never return null. Let's imagine a dialogue here. Let's say I call the software department up at Blip, and they answer me yes. And I want to talk to another employee named Jeffrey. And the lady on the line tells me to hold. And then someone picks up and is like, hello. So what would be the next thing that I would say to this person? Can you give me like an example? Any scenario you can imagine.
Are you Jeffrey?
Are you Jeffrey or... Yeah, that's a good example. It doesn't make any sense to ask him if he's no. Are you no? Like, does that make any sense? The same way in the human world, we want to ask someone if he is no, or the concept of no for us doesn't make any sense. It shouldn't also make any sense for objects. So we should also try to avoid, in any way we can, returning no or accepting no in terms of arguments. And this helps a lot in terms of maintainability. There's more to it, but I'll probably save it to another talk in the interest of time. And I don't master a lot of these concepts. I'm just here in spirit of sharing them with you. So let's talk a bit about Cactoos. Cactoos is it's an open source library. It's also made by the same guy who wrote the book of Elegant Objects. It's still in alpha. It has, like, for example, 50 or 51 issues open on GitHub, and you're free to open issues and contribute and submit pull requests. But basically what it is it's like you take the useful building blocks from Guava and Apache Commons and JDK that typically a lot of Java developers use and are very useful, and you apply to those building blocks the Elegant Objects paradigm. So meaning no null, no colon constructions, no getters, setters, mutable objects, static methods, not even private ones, among many other stuff. And I won't go into detail, but I'll just give you a few examples of how this translates, some of these translate in terms of maintainability and sometimes readability of the code you do on a daily basis. So for example, over there in Guava, I'm trying to join those three strings, and on the left and on the right, I'm trying to do the same, but using Cactoos. At first sight, maybe the Guava seems simpler, it has less code, but I'll ask you to take a moment and reflect on that code. Which one do you think is more readable or understandable? Who thinks the one on the left is more understandable or readable? Even if you don't know Java. And who thinks the one...
The one on the left is more understandable.
The one on the left?
Yes, because there already are words that you could join.
Okay. Okay. That's a viewpoint.
I think the most confusing thing about the right-hand one is that
I should probably have explained the first argument of join text is the separator for one join string.
Yeah, without the method signature, it's
I probably, and that's my mistake. I should probably have told you the method signature, but it's basically you can see it's basically doing the same thing, but only on the inside on how it works. It's actively not using any of that stuff that EO paradigm talks about. I have another example here. First one is in Guava, and the second one is in Cactoos. So you have a collection of lines, and I want to split them with a separator, and you want to split some text. The second example is doing exactly the same. So I ask you again, which one do you think is more readable or understandable, even without knowing any Java? It's no problem if you tell me the Guava one is more readable. I won't be sad or. Okay, who thinks the one on the left is more readable or understandable or maintainable for a fact? And who thinks the right one on the right? You like the one on the right? Okay. Again, they look the same. They're doing the same. But if you look on the inside, the way, for example, they're in terms of implementation, they're different. One is more procedural, and the other one is more object-oriented, at least in terms of the rules that are defined in elegant objects. Here's the third one. This one is...
Can we just go back for a second?
Yeah, sure.
So, how does the second one work? Basically, the split text returns is some sort of enumerable?
The split text class is exactly what its name is. It represents exactly what its name is. So you have a list of a split text of a text. Okay? You're not calling someone's job and ask them to split something for you. Every object is self-sufficient. Here, it's another example. We could also discuss in terms of readability. Maybe the one on Guava looks more readable. But again, if you look on the inside, one is more procedural, or one may lead you to one of those faults that is mentioned on elegant objects. And the other one is at least easier to understand because in terms of the objects being self-sufficient in terms of what they do. For example, on the second one, you're building a map composed of two map entries. The first one is you're building a map, you're putting stuff inside a map, and then you build a map. It's very subjective in terms of which one should we choose. I personally think that the Cactoos one is at least more understandable if I look at it from a distance. Okay, any questions so far? No? I mean, I can go for it. Okay, I'm going to sum up really quick. I'm not here to tell you that the code we were doing by not following elegant objects is crappy or whatever. No, nothing like that. But if you read the book, you understand some of the ideas, and they have a strong focus on maintainability, and that's something that I think at least is important for all of us. Like, we build production code every day, and a lot of the times when we're building code and we're building it alongside other programmers, this tends to be a shortcoming for a lot of us, and maintainability of the code we build every day. And elegant objects is in itself as a paradigm is an attempt to fight against that and make code more maintainable. Another thing I want to leave you with is this quote from Deming, that is, build quality into the product rather than trying to test it later. What I mean from this is you should always try to have quality from the start. Be it a school project or the code you do at work, you should always try to have quality from the start. With elegant objects and with Cactoos and other libraries similar, there's this huge concern that from the start we're worried about quality. For example, we're forcing a strict control of code quality. It's very hard to follow all of those rules. For example, in the book, you'd have to memorize them. It's very hard to follow them just on your own. But luckily, for example, there's a lot of tools that already exist that you can use depending on the language you're programming on, that help you, for example, force some rules of code quality. Coolis, for example, is made also by Jaeger, and all of Jaeger's projects use Coolis. And at first, when you start using it, you kind of hate it because your project never compiles, because it's always telling you that there's something on your code that's not right. But after some time using it, you start improving the way you code. And a funny thing is that it picks up a lot of the things we're used to pick up on a code review. Static analysis picks a lot of these even before the code review. Overall, it helps you become a better programmer. Okay, that's it for me. Thank you all for bearing with me. And if you feel free to ask me any questions, you can follow me on Twitter, GitHub. You can go to my page. Okay, that's all.
Do we have any questions? Or Philippe? Going once? Going twice?
Okay, can I have a question?
Sure.
You say that objects are not a bank of data.
Yes.
So
We shouldn't treat
why
them.
should I shouldn't treat them?
We,
My question was, so where is the best place to store data?
It's not a matter of storing data or not. It's a matter of how you treat an object. An object, of course, is made up and it encapsulates data and other objects. But the way you treat it, it's very different than just setting up, putting up some data, and then just putting up some procedures to mess up with that. It should be very enclosed, and it should have a very strict rules of how an object talks to other objects and how it's composed by other objects.
Any more questions?
Not sure did I answer?
Okay. I have another question.
Sure.
When you say don't use getters and setters, and then you show an example, but what I saw was maybe I just changed the name of the method.
It's not a matter of changing the name.
Maybe I was interested what that method do inside.
Okay. Maybe I can go back to that slide. It will be easier. Okay. Take some time to really look into this. What's happening here? You have a dog, okay, and sometimes it can still work as a getter or setter. But in terms of how you read it, it's very different.
It's more friendly.
It's more friendly. Yeah, exactly. But this is just in terms of readability. Like, for example, if you really want to avoid getters, for example, you can just have this rule where everything you need for an object to work comes in when you're initializing the object via its constructor. That's it. And in terms of setters, why not create another instance of another object that fully represents its state and is self-sufficient? Of course, you can think about, okay, but then I will just keep creating new objects, and what about memory or running out of memory? Okay, every situation has its own advantages and disadvantages. If that happens, I would say I would encourage you maybe to think of the problem in a different way. Maybe try to refactor it. Okay, but you can still do a lot while avoiding getters and setters.
You are saying that this methodology, if you have to choose to create another object with different.
For example, yes.
Then change
then changing the state of the object. Why not? Because that gives you, of course, that sounds at first like troublesome, but that gives you a lot of confidence in what you have, because you know that the state of the object won't change, right? Because you don't have any setters, and because you set up the parameters of the object as immutable. It's fine. If you can't change the state of the object, you at least have confidence that that object represents that state, right? So when you need some other state, create another object, and you're still confident that that second object represents its state at forward.
Yeah, I was thinking about this example as well, and I think the interesting thing is the conceptual difference, like the way you think about it, because I was thinking, yeah, this is a setter and a getter, but you don't think about them that way because they're actions.
Yeah.
You're sending messages to the object instead of thinking about changing internal data of the object.
Exactly. A lot of times it's that difference in terms of mentality of how you view an object for itself. So you could of course set the dog's ball or maybe whatever, but it's much more understandable when you don't think of setting some data and getting some data, but you start thinking of objects themselves self-sufficient.
I think that the tennis match was a good example because you have a tennis match has a location, for example, and you want to eventually get that location from the tennis match.
Yeah.
That is a getter in a way, but you don't know it's a getter because it may not be a getter.
Yeah.
Basically, you just don't treat them as getting sent. You just treat them as get me this information.
Yeah, exactly. Get me another object or get me information I need. And it's all, in a way, it's you still have guarantees that, for example, that tennis match, it won't change. Like once you create it, once you create an instance of that tennis match, you know that its state won't change, right? And it obeys the contract. So whatever, the data might come from different sources, but since it obeys that contract, you will always know how to get the information you want, to ask that object the information you want. Again, notice the difference in wording. Getting something and asking something.
And should every object, or should every class have methods that are not described in your interface?
You should always try to have them described in an interface. It has a lot of, for example, imagine you want to test that class, okay? In some, or you need, you know, you're going to use that object in another test for another object, okay? But you want to mock or stop that object. If you make an interface of it, no matter the number of functions you have of that object, if you have an interface, you can easily create like a fake version of that object, and it still obeys the contract you define for the initial object. That's one way of saying it.
Any more questions? Thank you, Felix. So now we're going to wrap up and head to